Good morning. Welcome to the CIDCI Online Salon Series. I'm Margie O'Driscoll, and on behalf of the Center for Innovation in the Design and Construction Industries Board of Directors, I'd like to welcome you here today. I'm particularly delighted to let you know that this will be the last time you will hear me introduce and welcome you to a CIDCI event. We are transforming ourselves away from a hard-to-remember acronym to a more succinct name that better describes our mission, the Center for Innovation. We plan to keep the CIDCI Foundation as our legal entity, but henceforth, hope you'll find it easy to remember who we are with a name that responds to our mission and goals. We'll be launching a new website next week and look forward to your comments. We'll continue to offer the same great programs, including the Research to Practice initiative, which invites students from anywhere in the world to submit a solution to a wicked problem in the AEC industry. We will be awarding at least $5,000 in prize money to individuals or teams. We would like to thank our sponsors who support all of our work, including today's webinar. Thank you again. Today, we are so delighted to feature Kurt Ameringer from Dassault Systems. His presentation is entitled, "You Can't Whistle a Symphony." He will share how process change and best practice experiences from nearly a dozen industries are transforming our profession while achieving an increase in performance and safety and lessening the impact on the environment. Although Kurt probably needs no introduction to any of you, I would like to say to his father, who might be listening, he has spent over 20 years helping companies in business transformation by identifying process change, increasing efficiencies, and driving innovation. He joins us today from his home in Portland, Oregon. Kurt, welcome. We're so delighted to have you with us.
Well, good morning and thank you. And hopefully this unusual sun that we have up here in Portland has me backlit this morning. So we'll take advantage of that and enjoy it while it's here. Well, I did want to say good morning to everybody and thank you so much for inviting me. I wanted to thank Margie and the folks at CIDCI, or as we now know, the Center for Innovation, for the opportunity to speak with everyone. And I titled this, "You Can't Whistle a Symphony," which is a subset of a quote that was taken from, it says, "No one can whistle a symphony. It takes a whole orchestra to play it." And that was attributed to Halford Lecoq. Very similarly, Michael Jordan once said, talent wins games, but teamwork and intelligence win championships. And both of these quotes really speak to this idea of collaboration, which has been at the heart of my personal journey, which is to understand how people are improving the ways that they work together to have better results in really everything they do. So rather than bore you with all the specifics of my past and activities, I just want to start off by saying my name's Kurt. I'm a recovering architect. So they say the first step to recovering is acknowledging that there's a problem. So I guess going way back, when I was 8 years old, my grandfather, a general contractor, took me out onto a job site, gave me a broom, handed me a dustpan, and you could say introduced me to the concept of eliminating waste in construction. So, quite a number of years later, in I think it was 2000, after a number of years working in the architectural space, creating 3D models of buildings to be able to produce drawings and schedules and other pieces of that, I started my journey to really change the way that I thought of, or I guess the way we think of as an industry, design and construction, and really wanted to push this idea of moving from working in 2D and to help start people to understand the value of what was eventually branded as BIM. And so that was where I kind of wet my feet on the technology side. Geez, 22 years ago now. And about 3 or 4 years into that journey, I started then looking at how BIM could be leveraged into construction, and started working with some of the general contractors in the Bay Area to develop workflows and solutions that populated eventually what was branded as VDC. So after 10 years within that space, I made a lateral. I started looking around at other kind of activities that were happening in the world. And I moved from focusing on best practices in construction and really wanted to start learning about best practices for manufacturing and experience this idea of PLM, product lifecycle management, and where that could help inform a lot of our decisions. By this point, BIM and VDC had a pretty good hold in the space. They were doing what they do, and I was looking to take that a step further. And so that was 10 years ago. where I started that leap. And that actually led to where I am today with Dassault Systems, which is leveraging this now 20 years of experience as a technologist to investigate how we can improve, again, how we collaborate, how we work, and really in the recent years, looking at this concept of experience. So all that being said, I guess to get started, I want to take a look at this with the end in mind. So start at the beginning, look forward to where we want to go. And this is the virtual city of Rennes. Rennes is one of a number of cities that's been virtually built with a digital model of the entire city. If you're not familiar, Rennes is the capital of the Brittany region, and it's the second fastest growing metropolitan area in France. Estimated population somewhere just under 500,000. And this data set that we're looking at, Virtual Rennes, has been created by combining different data sources in a single unified referential. It's constantly updated as new information comes available, so it's really becoming its living and breathing entity that combines, the buildings, the site, the GIS data, really everything out there that's available. So it becomes an accurate and reliable virtual equivalent of the real city. And it's something that officials within the city, the residents, businesses, developers, utilities and service providers, anybody within that space can look at, can simulate, can virtually experience and visualize this city with a holistic view of how it may evolve. Even in some cases, collaborating on sustainable solutions for the urban environment here, where we're looking at, for example, how somebody might move through the city in on a bike and looking at traffic patterns and how impact, all of that's been laid on top of this. And so we're also doing similar thing over with Lyon. And again, I mentioned there are a number of cities around the globe where this is being engaged, but I want to be clear, this is not just a collection of massing models. It's not a bunch of files that have been referenced together as a pretty picture. This is really a fully detailed data set of the entire city, where literally every building, every system, in some cases, every tree has been populated in a single integrated virtual twin. So leveraging this information at scale for the development of the entire urban environment that's constantly evolving has become much more manageable than it would be otherwise. And so this makes coordinating the renewal and planning of buildings, utility networks, again, mobile systems, whatever infrastructure there, less of a challenge. And it enables people to look at long-term planning and decision-making to be able to accommodate the needs of the residents both today and downstream into the future. So with this virtual twin defined at this level of information at this scale, key stakeholders are really able to engage in a collaborative effort to digitally drive a sustainable transformation of the city, with potential to be able to anticipate and really plan for a more livable, resilient urban area by leveraging and interpreting all of this data. So I think about where we stand with building information modeling today, and I see a world of potential in expanding that information from that single entity to that entire city, and being able to virtually build with this level of detail, that again, that fabrication level of information, and the opportunity to leverage that data for moving beyond BIM really becomes exponential. So I said twin. There are a lot of discussions about twin, virtual twins, digital twins. My grandfather, who was a twin, but what is it? And when I like to start off, I think about, again, this idea of capturing information. And a lot of us are doing that today within the cloud, within server systems, whatever it is, we're storing files. And this twin can store files. I mean, it's not like a common data environment where we're just uploading project files to a cloud or some repository. It's where we're actually integrating this information and starting to make it actionable. So to frame this a little bit differently, when I think about what I see as most of the digital twins that are available today, I see these as being purpose-built. Somebody builds a twin and a BIM, it's intended to produce drawings, or maybe it's intended to do structural analysis, or maybe we're starting off by capturing existing conditions, or we're building something to do construction simulation. But from my experience, I found that a lot of these twins don't really cross the border between those different sections. In other words, one that's built to do models may not be built appropriately to do simulation. And the one for simulation isn't built properly to do sequencing. And so, how do we integrate this information? How do we be able to do more than serve that initial purpose that was specific built with this information? And This idea of a virtual twin starts to go beyond that. It captures and communicates this extended data in a standardized business semantic so that it can be used for more than that single purpose. So in other words, that virtual twin is capable of doing all of these different activities. And in fact, it can create these artifacts like BIM or drawings or whatever it is that we're looking at as a digital twin. But the virtual twin starts to live and breathe as this evolving reference that can grow again as the city grows or as the project grows. And then taking that one step forward, it starts to support a synchronization of business processes and our activities that provides this secure integrated point for all of the project information to come together to really be experienced, to allow this capitalization of business knowledge and process. And so as I look at it, this starts to become a business platform. It starts to connect all of the participants that are in our value chain. So some examples of how that works. This is a team from industrial equipment. And in this case, they're looking at doing structural analysis on a component that they're working on. And even though they're working with this PLM, file-based central repository of information, which again, we kind of looked at as being the holy grail, what they found was that sharing all of this information, making the communication between all the parties, taking the time to optimize the model to be able to do these activities with it, be it the designer working on something, the pre-processing engineer fixing things, the simulation analyst going off and making changes, running the simulations while the design's changing. All of this became problematic. And when we looked at this process and all of the data that was going back and forth, we started to realize that when the team was working in that unified environment on that single repository of information that was integrated, they were communicating together, they were designing in context together, they were making decisions together in that same model at the same time without stepping on each other's toes. The time to find solutions was dramatically decreased. In this example, going from, I think, 15, 16 hours down to 1 hour of running that simulation. And as we start to automate those things, we can even make that faster. But where this becomes, to me, interesting and exciting is not just in the time savings, it's again, that ability to communicate. So once we've run these simulations, all of that information, all that data is made available in a single unified environment where somebody even as senior as myself can get in and easily review all the options, all the decisions, who made the choices, what was the process that we went through to get to this point, and then able to make a much more well-informed decision about next steps, about how to move forward, about where we're going with these decisions. In this example, we're looking at the environmental impact, the delivery schedule, the cost of what we're doing, who the trades are that are involved, all of this. And it's, again, put together into a very consumable environment to make sense of. So another way to think about this, I'm not talking about decision-making, but really about communications. I mentioned workflows earlier. We can debate the workflow managing an RFI as this is trying to lay out between all the parties. I mean, I've worked with teams that have had even much more complex processes than this, and I've seen people that are just simply relying on their email to manage this information. But the point is, I guess I would ask, how many documents are created in your personal RFI process? How many emails are you exchanging today? How much time do you spend managing just the exchange of information across parties that are involved? And the numbers up here in the upper right-hand corner I found a few years ago and are indicating that on average, it takes about 2 work weeks to be able to get a reply to an RFI. So again, I've turned RFIs around in less than an hour, but on average, metrics are saying 2 weeks. They're also suggesting it costs roughly $1,000 in, I guess, billable time to be able to make that response, again, on average. And they're suggesting that 1 out of 5 RFIs go unanswered or potentially get lost. I've not hit that metric myself, and I think we could debate any of these points at length, but I would ask you to look into what's your process and how much time are you spending, how much money are you spending with all of these steps. Just mapping this out, I think I counted somewhere around 11 or 13, so a dozen emails back and forth, multiple Word docs, Excel sheets, managing all these steps. And even if this is in a dedicated point solution that's built to manage RFIs, how much time are we spending, again, communicating with these artifacts and sharing this information, where we have to go back and say, which email did I get that had that information in it? Which version of that file was the most up to date? All of this gets tracked. And so as I'm looking at how that's engaged by contrast within this idea of the 3D experience or this process environment, right out of the gate, we can simplify the process. We can start by eliminating all those emails, all the documents, all of the artifacts that are outside of this space. But if we want to start with a file, if we want a handwritten note, that can be saved and attached to an action, an activity. And once that activity or that action has been created, it becomes visible to all participants within the project, all the impacted parties. And that action can have all of the relevant information attached to it. So those could be cut sheets or the scan of the field sketch, or even the actual geometry that's in the digital twin associated and connected with this activity. And this then can eliminate all of these activities where, again, we're tracking and tracing the receiving, the delivery, the notifications. All of this can slide away. And at any point while I'm working in this, I can stop and ask, where is this? Okay, we submitted this 2 days ago. What's the question? And bang, I figure out, oh, it's in research. Bob over in research has this. It's been there for how long? What are the next steps? All of this becomes visible to, again, people with the appropriate level of access to this information. So it, again, stops a lot of that additional communication requiring emails and documents. But if we want to create those artifacts, we actually absolutely can export those at any moment in time, share them, make them available. It really boils down to what is the process that we want to engage and how do we want to do this at the end of the day. So none of these are required, but they are optional if you want to choose them. But what this does is, again, it starts to simplify a lot of these workflows. It starts to improve that communication between the various parties. And it starts to create this digital continuum of information that goes beyond just authoring, building a model, creating a schedule. It unifies this information to help us make better decisions. But it also then starts to become that platform that impacts literally all projects or all aspects of the project life cycle and our business. And I'm going to spend the next few moments here just really kind of explaining how that business transformation has occurred in some of these other industries that we've referenced. So as a starting point, I guess I'll start off with a short story about Boeing, possibly one of the gold standards, again, of process change. And I think Boeing started this journey back in 1989 when they created a DMU, a digital mock-up. That's a model with fabrication level of detail of everything for their 777. So all of the shell, the skin, but all of the components, all the fasteners, all of the systems, all of this was modeled internally to create this DMU. So again, it's not the design intent, it's really being able to run a QTO on every single fastener that's in this, in this model, and being able to then to leverage that information across the life cycle of what they're doing. So now, nearly 30 years later, in 2017, Boeing and Dassault reached an agreement to develop a second 30-year partnership. And the focus of that partnership is really on designing the next generation of aerospace solutions to modernize the entire production system at Boeing and to be able to enable Boeing to deploy new services. So, and as I mentioned, this is a partnership. So this is becoming a end-to-end collaboration, digital collaboration, really, of design, engineering, simulation, analysis, manufacturing planning, even shop floor execution, to be able to reduce challenges in integration and improve costs, improve productivity, facilitate or foster new innovation, and to be able to aid in the introduction of best practice processes to deliver standardized work across the entire value chain. And that, again, starts to become interesting when we look at projects like the 787, where you may have had wings being built in different factories in different parts of the country, brought together and assembled in one, centralized location without any hiccups or surprises or challenges along the way. So this partnership is really expected to find and eliminate potential risks, quality issues, challenges before production by being able to provide a reliable and actionable real-time information with, I won't say seamless, but near seamless communication throughout the entire enterprise, and then engage the supply chain as well. And so that's for this generation of product, but also for future generations of product. I'm going to come back to that topic of product in just a moment. But again, this idea of digital continuity can improve data analytical capacities really across the entire life cycle. So even down to impacting sales, marketing, next generation development. And I would point out that this idea of 30 years, that's a lifetime, right, in our industry with the projects that we're working on. But it really demonstrates the commitment to changing the workflows that are being used today, and this idea or desire to improve how we're working tomorrow. So another example, and I take this both from automotive and aerospace, is this end-to-end supply chain and optimization that's going on, which provides a level of control and insight to transform this supply chain planning from a cost center in many cases to a revenue generator. I guess I'll just say each step of the supply chain that we're working with can be optimized, from strategic planning to long-term, looking at critical details, all the way down to the point of execution to be able to improve service. And when we talk about just-in-time delivery, this is where in automotive we can make changes and have products ordered in the morning and delivered by noon and ready to be installed into a product. They've optimized that process to such a degree. And I realize that's not going to be the case in a lot of construction projects, but the lessons learned that are in here of logistics planning, of production scheduling, of workforce planning, all of these things can be integrated into what we're doing. Now, again, manufacturing is a complicated enterprise, a complicated affair to work with. And this hyper-connected, fast-evolving marketplace that we're working in really adds to that complexity. So as we're looking at this pressure to keep up with digitization, the competition, the customer demands, we're having to find ways to become faster and more integrated, more agile. So that being said, I think that if we can simply look at understanding what the demand is going to be, being responsive with the supply options we have, and then take the time to look at production planning, workforce planning, production scheduling, logistics planning, all of these things are having an impact in the way automotive and aerospace are coming together. And that level of communication and coordination is definitely something that we can learn from in the construction space. And so to that end, I won't bore you with the audio on this. This is an example from Bouygues Construction. And Bouygues partnered with Dassault with the ambition of building a next generation of solutions that will address the construction industry's really key challenges and support this idea of customization at scale. I mentioned product a little while ago, different from project. You're going to hear that distinction pop up a little bit in the next few moments as we talk through this. So this was an initial pilot idea for Bouygues, and it was a critical point within their digital transformation strategy that they're working with. So the company engaged to try to define new work methods and improve the way that really all stakeholders on a project are collaborating across that value chain. And their end objective is to deliver tailor-made construction at the end of the day with industrial methods. So they're developing a digital project management platform on the cloud to become the collaborative solution for managing all the projects for all the stakeholders. And really at the end of the day, they're just looking to break down the silos in the ecosystem and develop this project-centric approach. So I guess to ensure success at the end of the day, Bouygues and Dassault both work together within this value engagement framework. It's a methodology used that's a consultative approach to be able to design, to quantify, to be able to create measurable business values and outcomes together, where both parties are bringing something to the table. And then that common objective is then the transformation that we go through of that ecosystem or that piece that we're addressing. It really allows all of the stakeholders to benefit from this collaboration of the virtual twin. On the bottom of the screen, you do see a link from our website at 3ds.com where you can actually get more information about this project. But the long and the short is that this partnership is playing an integral role in helping Bouygues to become green, to become more socially responsible, more environmentally responsible, and to be able to address their sustainability challenge, where they've made a commitment to reduce their carbon emissions by 40% by 2030. So, again, they're looking to make significant impacts in the way that they calculate and optimize their carbon costs, by the way that they're managing material resources, by the way that they're really providing value to everybody within this project. And so this process, this streamlining of everything from design to fabrication to assembly, they're looking to be able to reduce waste on the sites and on the factory floor by having better analytics, better metrics, and better communication. And so Bouygues is in process right now of their rollout, which is targeting, I believe, some in the neighborhood of 15,000 users engaging, communicating across this platform. So a moment ago, I said something about product, and there's a distinction between a project and a product. I'm not going to dive into this wholeheartedly today, but again, at the bottom left hand of your screen, there's a link. If you type that in, it can give you access to a white paper that runs through this whole concept of productization. But in essence, what we're looking at is that the trades-based construction and assembly process that we work with today, even when performed off-site, present massive risk to their schedule, execution, financial. There's challenge hiding wherever the trades can come together. So one trade intersects or overlaps with another. And mass production, what we think of today as prefabrication, has really not been able to accommodate local markets. That specification. They just don't support sufficient variation. And so this approach, talking to people over the last 20 years about this, has been repeatedly pushed back on by owners, by occupants, by people who expect this, this bespoke, hyper-customized solution. And so as a result, standardization of our built environment, be it an office, a hospital, multifamily housing, even infrastructure projects, has had limited appeal at the end of the day. And so this concept of productization is a different approach. And it engages this new level of, we'll say, value and scalability. At the heart of this are modules. Okay, nothing new there, a pod. But these construction modules are integration ready. Okay, they're modules that incorporate multi-trade assemblies, standardized interfaces, and generative variants. So they get organized as product lines that align with business objectives of a given owner, the general contractor, whomever is providing this product. And again, they're managed as products independently of the projects. And they're built in a fashion to be able to enable nearly infinite variables across multiple projects. I'll show you an example of exactly how this works. But in essence, every module or every component is intelligent enough to be placed and to automatically configure itself to any unique conditions on that given site based on rules that we define. So, well, again, I'll come back to that in a moment. But as property owners, as developers are seeing this increased value in productization, this is an opportunity where general contractors are starting to reframe their role as this prime integrator, the commander-in-chief of the construction. And this prime integrator is now in a position to be able to deliver value to owners by managing all of the virtual makers, if you will, orchestrating site logistics and finding new approaches to manage procurement. So if that's happening, now subcontractors, specialty contractors are accessing, I guess, new revenue streams as these virtual makers. And so this is someone who is going to be collaborating with the designers, the general contractors, even directly with the owners, capturing the information of all these entities into that product that we do. And again, that product spans projects. So it's what we refer to as done in an off-cycle phase, meaning the work product informs the design and can be used across multiple projects. So we create it once, We use it many times. Like they've always said that, you know, Boeing designs a plane once, they build it many times. Well, actually, each one of those planes is unique, and that's a very similar process to what we're talking about. But this also then starts to engage in and support this idea of microfactories, where we're seeing this new category of value chain players that are basically local entities that produce locally and deliver integration-ready modules to be able to create value in that, you know, in that space. And so this idea of hyper customization is pushing people to, again, collaborate together more efficiently, because we're starting to design with the end in mind. And that's why I started off with the city at the beginning of all of this, because we want to say, where are we going with these pieces? And all of these pieces need to come together to form that whole. So as we're working with this, we're engaging the designers, the manufacturers, the fabricators, the operators, you know, to make better decisions about those design choices early on. And it's really pushing, I think, all of the participants in this collaboration process in this construction space to rethink how they can best deliver value. So that being said, quick example, you're probably familiar with this project, at least I would hope that you are. I am referencing an article from Fast Company. Again, the link is at the bottom of the slide here if you want to take a deeper dive into it. But this is an example coming out of, I would say, one of the leaders in the high-rise market in the world today. And if you read the article, you'll get the background on the Sharples brothers and their co-founding of the New York architectural firm Shop. Shop has been working with this idea of prefabricating architecture for over 20 years. And one of the best known examples of this use in North America, or potentially globally, is the Barclays Centers that we see here on the screen in Brooklyn. And next to that is an adjacent 32-story B2 apartment complex that I believe is the tallest modular building in North America. But what has been key to their approach is that they're looking at how the building is built is going to impact how it's designed. Okay, again, that's how we build airplanes, that's how we build cars. You don't figure this stuff out after you've designed it in other industries. And so their design process follows the impact of the manufacturing process, again, starting with the end in mind. So Shop is evolving, and back in 2020, they established a company, Assembly OSM, and this is a modular construction company. And their teams are engineering components and sub-assemblies. So again, structural steel, walls, wood, floors, ceilings, facades, MEP, HVAC, you know, kitchen, bathroom, all of the different components, even down to building cores with elevators and stairs, to fit within this single platform of infinite combinations and variables. So these individual models can take a wide range of different dimensions and shapes, enabling, again, tremendous variability in the building type, the size, the layout, the usage. And so these buildings are designed by Assembly OSM as a 3D digital twin that really embodies the dimensions and materiality of every single component. So when they're building these models, again, it's not a design intent model, it's a fabrication model. It's looking at every single component automatically being modeled in this space in, quite frankly, less time than it typically would take to create the BIM. And by putting that together, then the components can be manufactured from that same model by the company's participants in the supply chain. And products are then assembled by Assembly OSM and stacked on the job site. So each end result that they're working in aims for this idea of high quality performance, high-end aesthetics, sustainable materials, and cost-effective delivery. All of these are coming together to impact the operating expense. And projects that they're delivering are benefiting from a significantly reduced time to completion due to this forward thinking ahead, pre-engineering about this. So I want to be clear, this is not just offsite manufacturing. We're not just building a building inside of another building. We're not putting the workers undercover where they're dry and safe. There's a lot more to this as far as being able to plan, to be able to integrate, and to be able to understand how these components are come together on the site, so that as the people in the shop under that cover who are safe and warm and enjoying their jobs are delivering more value. So the assembly approach has been to decentralize this process with individual suppliers manufacturing components in various locations that are then put together, delivered to the site, and lifted into place to be able to develop a building in roughly half the time that it takes from a traditional construction process. And that's half the time of manufacturing the parts and assembling them, as opposed to bringing raw materials and building on site. And they're positioning that somewhere around 85 to 90% of a given project can be done in this capacity. So that being said, I also want to take a little side to look at the entire ecosystem, if you will. And I'll say, right, you don't plan to fail, you fail to plan. So no one plans to fail, right? I recently came across this story, I think it was on 60 Minutes, about the Rubik's Cube competitions. These people that solve those puzzles in less time than it takes me to say Rubik's Cube. But they indicated in these competitions that the competitors are allowed about 15 seconds to view the cube, to look at it, to study it, before they attempt to solve the project, right? At which point they set it down, the buzzer goes off, they grab it. And right now, the current world record is somewhere around 3 seconds to be able to solve this puzzle, right? Which means they spend almost 5 times as long planning to solve this project as they spend in execution. Now, I'm not suggesting we spend 4 years planning for a 1-year execution, but I do see opportunity to improve our planning. And so that brings us to this idea of MBSE, or model-based systems engineering. And this is the topic that's really taken some time for me to wrap my head around. And I'm sure there's a lot more that I have in front of me to learn about this, but I'm going to take a swing at introducing this as a concept. According to INCOSE, INCOSE, the International Council on Systems Engineering, MBSE is defined, look at my notes, as the formalized application of modeling to support systems requirements, design, analysis, verification, and validation activities, beginning in the conceptual design phase and continuing throughout development and later life cycle phases. Or, I guess you could say it's the practice of developing this set of related system models that help define, design, and document whatever this system is that you're building. Okay? It's a methodology that forces or focuses us to create and use specific models as the primary means of information exchange, okay, rather than using a historic document-based, again, Word files and so forth, going back and forth. It starts this model-based process. I could probably go, well, if I had enough information, I could probably go for the next 2 hours just discussing this topic and would just be scratching the surface. But to suffice to say, this is a process of limiting risk and improving predictable delivery by improving visibility and traceability of who's doing what, when, and why to the project requirements to ensure that they're met in the finished product or project. So MBSE is most mature, commonly seen in aerospace defense, in rail, in automotive, in industrial industries. And this is an example from mining. So to take a little bit deeper look at this, again, that's just going to scratch the surface. This is an example where I'm looking at industrial equipment. And so as we look at this excavator, the excavator is being defined not as geometry, but as a system of systems. Okay, so the requirements, what does it need to do? The function, how does it do it? The logical relationships, how these pieces come together, and the physical objects, again, how big is it, etc., have all been mapped in this MBSE approach, along with the system controls and even down to the software necessary to drive that excavator. So on the right, you can see all of the elements coming together to design the product, but as well, they're looking at how's it going to be assembled. Okay, think about means and methods. How is it going to be delivered? Think about logistics. All of this is being simulated prior to finishing the design, even down to the point now of where we're looking at a worker servicing the object or assembling the components. So what are the ergonomics that we can get in there? What level of detail are we working with? And as we have this information, we can then start, again, working together, looking at what if scenarios, looking at how are we working to solve problems. And so in this example, we can see the impact of maybe putting in a different controller, swapping out some of the hydraulic components, changing the dimensions of an element, and then what's the actual real world impact of those changes to that system. If we change the hydraulics, what is the impact? Is this going to work as we expected it to? So the simulation is not just looking at the visibility of an object on a site. It showed up it fits, great. It's investigating how the element performs in this actual kind of realistic conditions and what additional parts of the project might be impacted by the change. If we change that hydraulic component, what's the impact of the length of the armature? Will we be able to move that bucket the full rotation that we expected? And so this is combining engineering, simulation, visualization. Chances are the last car commercial that you saw was at least partially computer generated. And they're doing that to be able to speed sales so that they're filming, creating these commercials before that car comes off the production line. So, we're seeing the new electric truck. It doesn't actually exist yet, but the commercial's there and we can pre-buy it. This is part of that integration, and even down to optimizing manufacturing and now lifecycle maintenance and operations. Again, that end in mind, what are we doing on the service side to continue this information, do more with it? So another example in the rail space is where the train, the controller, the signals, the switches, in some cases, even the power systems are all being designed and tested virtually, working together as a system of systems. So again, they're able to look and say, if we change X, the size of the engine, what's the impact to all of these other systems? If we change the size of the HVAC unit, what's the impact to everything else that we're working with? All of that becomes integrated. And by doing this, this team can ensure, again, virtually zero defect products through digital integration of the components. We have people on site today that historically have done physical mock-ups, or they've done dry fitting of components at scale to verify that we can build this thing as we expected. We then take it apart, ship it out to site, reassemble it. All of that today is being done virtually. We're scanning the actual physical object and seeing how the pieces come together. So this is driving a cost savings, system optimization through both the virtual and hybrid virtual real evaluations while planning for operations by computing costs associated to assemblies aging. They're also, again, looking at that long-term impact of, if we design it this way, what's the impact going to be for maintaining this element? So they're able to shorten verification and validation phase thanks to this simulation. And this is where in aerospace, this is required as a means of, again, mitigating risk, but having that real validation that things were inspected, tested, approved prior to construction. So all that being said, I'm coming down to the end of the presentation here, so I appreciate everybody's patience with me, but this is just a simplified kind of idea of this model-based systems engineering. If you think about this as the standpoint of capturing the DNA of one of these products, this is a hospital example, and each one of those little modules is some aspect of a hospital room. It could be a patient room, it could be a operating room, could be part of the cafeteria, but all of these have been defined. And as we're placing them on the site, as we're automating this, and you've probably seen something like this in your generative design tools that you may be using, whatever those are, what we're getting is real-time feedback. So this is telling me how many of these units have. It's providing answers. Is the furthest patient room from the operating space, if that is important to me? All of this is being tracked and traced. And again, as we start twisting and turning and pushing and pulling all the model components, everything updates like you would expect. So nothing really new within that space. But what I think starts to really become interesting in this, and I'm just going to step ahead, is every one of these little Jello cubes that we're looking at is an actual module. And when we find a design that we like, a layout pattern, conceptual work that we want, we can simply change the level of detail that we're working with. And rather than working with these as those Jello cubes, we're taking this down to selecting components and actually locating all of the finished product. Okay, and so we replace that cube with a finished module. But again, I want to be clear, this is not just swapping out a block in our tool. It's not changing the family that we're working with. This is actually changing that level of detail to incorporate all of this information. And so as we look at this individual unit, I can select one of these Jello cubes and drop that unit in its place. And now I can see how that module would act and react within that area. And that starts to become important, obviously, because I want to know what's happening with that. But rather than just mirroring, arraying, copying this component, what we're actually doing is, as we've placed that one instance, we start then to replace all of them. So all of the individual components. And I'm just going to jump ahead here a moment. And so now we've swapped out every single Jello cube with the actual fabrication level of information. So we have the hangers, we have the HVAC, we have the actual patient rooms laid out, even down to the IV bags. You know, all of this detail is now automated within my model. And so if I want to know how many yards of hose line I have for those hanging bags, you know, we can calculate that information. But more importantly, we can say how many beds do we have, what's the actual number of connectors, et cetera, et cetera. And as we continue to develop that, each one of these individual units is smart enough to understand that because it has a relationship to everything around it, it's not just putting a wall on top of a wall, which is going to goof our constraints, right? It's starting to figure out, well, if these two pieces are coming together, we only need one wall. And as such, how do we frame that wall? And what are the elements driving the framing on either side? Do we need blocking to support these? All of these questions are automated and part of that DNA. So we're modeling all of the components to ensure an accurate bill of material, or QTO. And because we have all of that information, we're then able to do accurate analysis, accurate simulation, and even down to the point where, again, if we look on the right side of the screen here, we're doing this at the level of scale. So, you know, 40 plus kilometers of rail, every single component being modeled. Looking at data centers, even down to the cables connecting the different components, and work instruction, how are those going to be assembled? Validating ergonomics, do we need ADA compliance to be able to get in and safely execute these activities? All of these are additional opportunities to leverage that model to do more than just what we're doing today. So that being said, I see my buzzers going off here. I think I'm starting to cross the line of my time allotted. So I do want to just jump forward and say that if it wasn't clear, because I feel like I've just hardly scratched the surface on some of these topics, but as we're talking about this virtual twin, if it wasn't already clear, you know, design, communication, fabrication, simulation, collaboration, all of these are core benefits of this approach to a virtual twin. And as I look at the opportunity to expand that, you know, there are probably years of improvement that we could execute right now. But what's becoming interesting to my investigation in this is that every other industry that I'm working with is looking at extending the use of this data into operations and lifecycle optimization, and that is their end game. So when I go all the way back to, well, may seem like it was 2 or 3 hours ago to you, that starting with the end in mind, I want to point out that we want to think about that end in mind and how do we get there. Let's use that to inform the design that we're choosing. Let's use that to inform our means and methods. And so I just want to say, if I'm invited back, I want to take a look at how this is going to you know, be executed in other industries around the world, how aerospace is prevented unplanned downtime, or how industrial equipment's reducing their time to repair, how energy and infrastructure are streamlining collaboration, and really how so many other industries are capitalizing on this knowledge capture and best practice. So that being said, I just want to leave you with one last thing. Fun fact, I started off talking about symphonies. Wagner, the composer, is referenced as the first conductor who actually turned his back on the audience when leading an orchestra. Prior to this, apparently the conductors all stood to the side and looked at both the orchestra and the crowd so they could get the accolades coming at them, I guess. But you can imagine how little impact that individual would have had on the brass section, you know, facing the crowd. So I'm going to point out this last little opportunity required for change, and I'm going to leave you with one last quote. It's been attributed to a number of people. I may be dating myself if I mention Lawrence Welk, but you know, at the end of the day, if you want to leave the orchestra, you're going to have to turn your back on the crowd. So that being said, I appreciate everybody's time today, and it turns back over to you, Archie.
Kurt, that was absolutely fantastic. Thank you so much. So I have a question for you, which is you posit optimistic and efficient methodology going forward, what do you see as the primary obstacles going forward towards widespread adaptation of these systems? And do you think we'll ever get there?
Yes. So
it's an easy one.
yeah, absolutely. We absolutely will get there. To me, the biggest obstacle, this has never been a technology challenge at the end of the day. You know, technology is perfect. No, technology has lots of challenges, but the bigger problem is the people at the end of the day. My willingness to change the way that I work, my drive. Why do I need to change? I can get all the work done today the way I'm doing it. I can muscle it through and make it happen. What's the incentivation for me to make that change? And so is it meeting the green accords? Is it being more environmentally friendly? Is it worker safety? Is it just simply being able to do more with less? All of the studies that are showing we have more people retiring than entering the industry today. How do we deal with that? The lack of kind of what I would have said my age people in the practice that moved into other industries, apologies, rather than continuing to practice as architect, has left that gap, that void. How do we deal with that? Those are the questions that need to be answered that I think will drive us to this point. And it's going to take a better understanding of our end result at the end of the day to realize that we can have this bespoke mass customization. Everything is unique, deliverable, but we don't have to use the same stick by stick processes that we've had for the last 200 years to do it. So I don't know if that answers the question, but I think it touches on the idea.
We had a speaker a couple of years ago who talked about even with the same project teams, when you bring the same people together on a new project, they forget more than 50% of what they learned working together. So even with the same teams, we're not remembering things. We're remembering things for a particular project, not for the future. So I think that really it really affirms what you're saying. I want to switch gear to a totally different kind of question. Dean Reed, who's one of the officers of the new Center for Innovation Board, and I have been talking a lot about the thinking that will be needed to rebuild the Ukraine, hopefully sooner than later. And I look at what you posit for us and think about how valuable it could be for a country that's been, especially with its urban centers, really decimated. If you got a call from the president, saying, "Hey, how can you help us?" How could you posit a starting place from a place that's been as devastated as the Ukraine?
Yeah, that's a large question as well. I think I would go to my core today, which is infrastructure as a starting point, and identify what the needs are first and foremost. What's the existing condition, and then how do we improve that? So if we need roads, if we need rail, if we need water, if we need electric, all of those are they're kind of at a hybrid space. They're not quite at the level of aerospace and automotive, but they're also not quite at the level of building construction. So they're already investigating and executing against some of these MBSE approaches, or the idea of this product-based design that we are taking from automotive. That's where I would start. But then I would also say, what lessons can we take from that to facilitate enclosures, buildings, to be able to help protect people? And so, I've worked with companies that are actually putting together concrete buildings from a design, and they've automated the entire delivery from raw materials coming in one end of the factory to panelized construction coming out the other end that is delivered to the site and stacked. And that's something that in 3 months we could have housing in place. At probably less time than that if we investigated metal options or the other pieces. But politically, once that settles down a little bit, absolutely address the infrastructure, and then start figuring out how to recreate this world in a sustainable manner. And I think we're starting to see that as well with some of the cities that are being designed in the Middle East, where they're taking a completely different approach because they literally have a blank canvas. And anything that they do is going to have to be supported by this infrastructure. they're doing some interesting ideas about changing the way we live and changing the way we experience cities. But I think we could probably do a deep dive of a good hour talking about what to do to address the challenges that we have in Ukraine and other places that are in definite need of bolstering of infrastructure and the environment.
We have a question here from Chris Marolf. Chris, I've unmuted you. Would you like to ask your question?
Yeah, please. On one of your last slides, you mentioned that example of back-to-back framed walls and what that means for construction. And using that as an example, how does knowledge or know-how that you referenced there get into these models?
Well, so part of the framework, or that DNA that we talk about in MBSE, is, in essence, we're capturing rules about how these elements come together. So when I think 20 years ago, doing a early BIM, I started looking at unitized construction for assisted living facilities. And so I designed a unit, and I thought, wow, this is great. I can just mirror this. And now I have 2 units back to back. But then I realized I had 2 walls, one sitting on top of each other. And it took the human, me, we can debate, coming in and removing that wall and then figuring out how to do that, because now I couldn't place that wall as part of the unitized assembly. It had to be something separate so that I could remove it where it needed to be removed. All of that can be automated. That says, if 2 walls are in here, we're just going to take one of them out. And then we want to look at how the framing in that wall is going to react to what's connected to it. So in the case of a assisted living facility, we may have some medical equipment, we may have a television, we may have something mounted on the wall that's going to require additional blocking, right? So because of that, the relationships that we've established are intelligent enough that it says, if there is this condition, then we need to do this to change the framing to make it work. So it's really capturing that your best practice, your experience, the way you want to do things, and putting that into this information. So again, when I think about the early days of 3D and creating blocks, I could create an object and I could stretch it and pull it and it would change shape and do all kinds of cool stuff, creating additional components possibly. This is taking that to that next level. And you see this in automotive. You've seen this in a lot of highly customized buildings, where a building facade may be composed of thousands of unique panels. Everyone's different, but it's one object that's based on a series of rules about how it behaves and how it relates to the panels around it, that drives and automates that layout of all that information. So I don't know if that answered your question. It's something that does really have a deep dive of technical to get there.
Nothing for right now, it does. Thank you.
Right.
Well, thank you for the great question, Chris. And Kurt, thank you so much for a fantastic presentation. Unfortunately, we're sort of at the end of our time together, but you can be sure we're going to invite you back again. We'll see how much progress we all make as an industry in the next year or two. And perhaps we'll have some good stories to tell. Thank you. Thank you again.
Thank you. Absolutely. And if anybody does want to reach out, my email's on the screen, so please feel free.
Great. On July 15th, please join us when we talk with Professor John Gambatese about prevention by design. Prevention by design aims to improve safety and health for the design and construction industry through the elimination of hazards before they exist on the job site. He's also from Portland, Oregon, but trust me, we do talk to people outside the Northwest on our series. This concludes the Center for Innovation's online salon. This session will be recorded, placed on our website as well as YouTube as soon as possible. To join us for future webinars, please subscribe to our newsletter on our website, centerforinnovation.org. Special thanks to Katie Olson for keeping us on track and our sponsors who make all of this possible. Thank you for joining us. And as always, if you have thoughts or comments, please reach us on our website. See you soon.